Hi, I'm the math guy Steve. Let's try evaluating this integral. So when evaluating integrals like this, again, integrals can be complicated. They really can be, okay? So to try to evaluate them, my first attempt is try to use a u-substitution, right? So in this one, we have a 1 over x squared minus 1. So the only possibility would be to let u equal x squared minus 1. But then, again, if we have a u, if we're looking for a u substitution, we always look to see, is the du somewhere in the problem? So then du would be 2x dx. And again, this 2x part is not really in our problem here. So that's not a good attempt as far as evaluating this integral, okay? So our next step would be, well, okay, if we have an x squared minus 1, this is a fraction. So one thing to consider is partial fraction decomposition. Okay, so partial fraction decomposition, okay. Well, for short, I call it PFD, okay. Not PDF, okay, that's portable format documents, okay. Sorry, portable document format, okay, but PFD, that doesn't work, right? So partial fraction decomposition, okay. All right, so what that means is we want to take this 1 over x squared minus 1 and rewrite that as two separate fractions, two partial fractions or parts of one bigger fraction. So rewrite them as two separate fractions. So first, how we do that is by first factoring this denominator of this fraction. So to factor that, of course, that's difference of squares, right? So x plus 1 times x minus 1, okay? And then now we want to write that as two separate fractions. So something over x plus 1 plus something over x minus 1, okay? And now the somethings are pretty critical here. So when we have both of our denominators being linear denominators, then our numerators must be 1 degree lower than that. So in other words, constants. Okay, so here A and B. And now our goal is to find the A and B that make this true, that make it true for every possible x or for almost every x, okay? So we need to solve for A and B. This is really solving a system of equations, okay? Or find the A and B that make this true. Now, one way to do that is by multiplying both sides of this equation by the LCD. So multiply both sides by x plus 1, okay? So x plus 1 times x minus 1, okay? And do that here as well, x plus 1 times x minus 1. And this one, x plus 1 times x minus 1, okay? And things start to cancel. Things go away, right? So here, the whole denominator cancels. I'm left with just 1, okay? Whereas here, the x plus 1s cancel, so I'm left with a times x minus 1, all right? And here, the x minus 1s cancel, so I'm left with b times x plus 1, okay. So we got rid of fractions. No one likes fractions, right? But then, another way to solve this is by setting up a system of equations, meaning equate the coefficient parts on both sides of this equation. Okay, that's one way. Another way is to say, well, this is supposed to be true for every x, or at least almost every x. Meaning, let's choose some convenient values for x and find the A and B that make this true. In other words, conveniently, meaning let's choose x equals 1. Let's see what happens. If x equals 1, this should be true, meaning we get 1 equals a times 1 minus 1 plus b times 1 plus 1. Got it. So it should be true for every x, right? Well, if we choose x equals 1, we notice that, oh, the a term goes away because we get 1 minus 1. So this part goes to 0. So we end up with 1 equals b times 1 plus 1 is 2. Got it. So solve for b. B equals half. Okay, good stuff. Okay, we got b. Got it. Now we have to find a. All right. Well, let's choose some other convenient values. Say x equals, I don't know, -1. Conveniently, right? And by conveniently, I mean I'm choosing the x value that would make one of the variables go away, one of the a or b go away. If I choose x equals -1, we get 1 equals a times -1 minus 1 plus b times -1 plus 1. And notice what happens. This time the b term goes to 0, right? So we get 1 equals a times -2. I got it. So a equals -half. Okay. All right. So we found the A and B that make this true. This helps us in now evaluating this integral. Okay, so let's see how we're going to evaluate it. Now we see this integral can be rewritten as the integral of -1/2 over x plus 1 plus 1/2 over x minus 1 dx. Got it. And now it's a lot easier integral to integrate. And because because of the linearity of integrals, we know that this is the same as negative 1/2 of the integral of 1 over x plus 1 dx plus 1/2, right? Plus 1/2 the integral of 1 over x minus 1 dx. Now we can integrate these separately. And 1 over x plus 1 is pretty easy because that's just what we call a quick u-sub, right? Is that you don't have to write the u-sub part. It's just 1 over x plus 1 is similar to 1 over x, which is ln the absolute value of x, right? So 1 over x plus 1 is similar. That is, we get, this is negative 1/2 times the ln of the absolute value of x plus 1 plus 1/2 the ln of the absolute value of, again, same thing, quick u-sub, ln of absolute value of x minus 1. And again, once we're done integrating, we need to put that plus c, that constant, at the end, okay? Now, that's our integral. We're done. Except we need to check it, okay? We call it the Nike step, okay? Make sure you check it, okay? Okay, just check it. All right, so let's check it. All right, so how do we check it? Well, we take the derivative with respect to x, okay? All right. Now, again, because of the linearity of derivatives, we can separate this, right? So this becomes the derivative with respect to x of negative half ln absolute value of x plus 1, okay? Plus the derivative with respect to x of half ln absolute value of x minus 1, okay? And then plus the derivative with respect to x of c, all right? And I will take the derivative with respect to x of each one. Now, remember, the derivative of ln of something is 1 over that something times the derivative of the inside, right? So, and again, this negative half kind of just pulls out because of linearity. So we get negative 1/2 of 1 over x plus 1 times the derivative of x plus 1, which is just 1, okay? Plus, same thing here, right? It's 1/2. The derivative of ln of x minus 1 is 1 over x minus 1 times the derivative of x minus 1, which is just 1. And the derivative with respect to x of a constant is just, or a constant that is a constant with respect to x is just 0. Okay? So we get negative 1/2, and I'll factor out a negative 1/2. All right? And that is 1 over x plus 1 plus 1 over x minus 1. Okay, and we kind of showed earlier that with this negative half in there, we end up with 1 over x squared minus 1. So that was our partial fraction decomposition that we showed earlier. Okay, so when evaluating integrals, there's a few steps and they can be difficult. There's a lot of different versions or different methods. Okay, you want to try a u-sub first, but if not, then try that PFD. Okay, the partial fraction decomposition. All right, because that may help, especially when you have a fraction. Okay, usually that lends to or kind of hints to using a PFD. Okay, all right, especially if that denominator is factorable. All right, okay, so always remember, math is everywhere.